Greetings. Today we will be presenting our project for KIX2006 Engineering Economics and Project Management. The title of our project is Compact Electromagnetic Pulse EMP Defense System for the Johor Military Force. My name is Abdul Haziq bin Ramli, U200562.
My name is Satisha Onalaki Darman, and my metric number is 23005173. Next.
And I am Muhammad Sharif bin Muhammad Hamizan. My matrix 230662227.
My name is Sharan Emmanuel Anlaki Chandragan. My matrix number is 23058930.
Electromagnetic pulse, or EMP, is a critical threat to modern military systems. For Johor's homeland security, the Johor Military Force, or JMF, relies on essential assets like GPS, radios, and drones, but these are all highly vulnerable to EMP attacks. To put this into perspective, imagine a scouting drone launched for surveillance missions. An enemy force could instantly neutralize it with a targeted EMP wave, cutting off communications and disabling the drone mid-air. This is not science fiction, it's a real vulnerability that Johor cannot afford. In response, our project introduces a portable and scalable EMP shielding system designed to ensure uninterrupted operations during EMP disruptions. Our solutions targets command vehicles, communication relays, and tactical equipment, and will be deployed through 10 modular EMP protection units across strategic sites in Johor. And based on our feasibility study, this system will be technically compatible with JMS current equipment, economically viable and scalable, and also operationally adaptable for field deployment. We have planned a clear timeline. Feasibility and design begin in July 2025, prototyping by mid-2026, deployment and manufacturing from September to November, and finally training and audit completed by March of 2027. This is a 21-month window to full system deployment. Lastly, these are the 8 major stakeholders who we have identified, each playing a vital role in driving this project forward.
From the previous slide, we saw that
each of our stakeholders has their own roles and contributions. In our organization background structure, we can look at one example. The example is the technical team. The technical team consists of system engineers and EMPs integration specialists, whereby the technical team will report directly to the project manager, and the project manager will report directly to the project steering committee. And the rest of the other teams will report also the same way.
Okay, now I would like to explain about the project timeline and schedule for our project. Our project is included multiple phases. The first phases are feasibility study and system design, procurement planning, prototyping, pilot deployment, full production, system validation, training and handover, and our final phase will be the final review and the audit. For the detailed project timeline and schedule, can refer our report. Next. So this slide, we would like to explain about the critical part that we did for using Gantt chart for our report. The critical part that highlighted in red shows the critical part for our report, which is represent the sequence of dependent tasks that directly determine the project's overall durations. We also include a visual representation for our project timeline, which can refer the down one, the blue color one. Okay, now we look at budget and resources. The budget and resources for our project is allocated for project duration for 21 months, which is from July 2025 to March 2027, and the goal is to develop and deploy 10 fully operational EMP devices. The resources that we included in our project is human resources, technical resources, material components, and logistical support. For the detailed list of the resources, can refer to our report. For budget, we have come up with the 3 options for our budget list. The first option would be the modular serial deployment, which is a mid-range base case, and this one is for scalable design with the NATO grade modularity. For the full detailed list, we already included in the report, can refer from there. And the total budget for option 1 is 2,290,500. For option 2, which is the communication hardened technical build, for higher performance and higher cost, the total budget is 3,629,000. And the last option for our budget is the mobile compound and a vehicle-based EMP defense. This one's for the strategic mobility and compound flexibility. The total budget that we listed is 6,314,000. Okay.
The compact EMP defense system brings several key benefits. Operationally, it ensures the Johor Military Force can maintain command and communication during an EMP event. Technically, it introduces a modular, scalable solution that can be integrated into existing systems. Financially, it lowers long-term costs by preventing damages and downtime. However, there are disadvantages too: high upfront costs and integration challenges. But then when we consider the broader impact, such as enhanced national defense readiness, the benefits clearly outweigh the drawbacks.
Okay, the next one would be the benefit ratio calculations. For our benefit ratio calculations, before we do the calculation, we do some assumptions do our calculations. For the first table that can refer from the slide, that one assumption that we made is for project life, we assume 5 years, discount rate 5%, salvage value is 200,000 for all the 3 options, annual O&M cost, which is the operation and maintenance cost, we assume 100,000 for all 10 units for all 3 options, and the annual benefits will be different for each options. As the second table will be for the annual benefits assumptions for option 1, which is the 700,000 annual benefits, option 2 950,000, and option 3 is 1,600,000. All the justification for all these assumptions can refer our report. Okay, and then we did our benefit cost ratio calculations. For option 1, we get 1.18 benefit cost ratios. For the detailed calculation, can refer from this slide or our report. Option 2 and option 3, we got 1.05 as the benefit cost ratio.
For incremental BC analysis, we must first justify the MARR at 5.5%. The MARR is the minimum acceptable rate of return. It is the minimum profit an investor or company expects to earn from an investment project. It acts as a benchmark, ensuring investments are profitable and strategically sound. So justifying our MARR at 5%, the reasons can be boiled down to a low risk due to guaranteed payment, stable macroeconomic conditions, and alignment with national strategic interests. The details can be read in our report. For the incremental BC analysis, here I have shown the equations that will be used to calculate the IRR. But instead of using the equations, we opted to use Microsoft Excel, in which the values can be plotted into each cell, and then we can use the built-in function to calculate the IRR for each option. Next, we can compare each option to each other to determine and rank the best option. So we compared each option with each other by using the option 3 as our base case, and we got the ranking in which option 1 and option 3 is the number 1 choice, option 1 is the second choice, and the option 2 is the last.
This slide expands on our project by highlighting the motivation and strategic integration. EMP threats, both natural and man-made, pose a serious risk to modern defense system. Our solution is a portable, scalable unit that protects communication, command vehicles, and fuel systems. Deployment will be phased across Johor, targeting command units, communication hubs, and high-value logistic areas. Importantly, it's a state-federal collaboration involving JMF and ATM, focusing on defense within Johor. Our planning process followed a structured approach using project management principles. It began with a feasibility study to assess the need and viability of EMP system. Then we moved through the design, prototyping, testing, and deployment. A work breakdown structure was used to divide the project into manageable tasks, which was scheduled and monitoring easier. Through this process, we incorporated feedback loops, performance checks, and risk assessment to ensure the project remained on track and aligned with defense goals. Next is the type of constraint. Every project faces constraint, and ours had 3 major types. First, logical constraint, like the need to finish design before testing. Second, physical constraint, for example, weather can limit field testing. Third and most important here are resource constraint, with only 1 EMP specialist and limited shielding material. Task scheduling had to be precise. In our priority matrix, performance is the top priority. It cannot be compromised. Time has some flexibility, and cost is the most adjustable.
So classification of problem. For classification of problem, the implementation of priority matrix is used with 3 parameters and 3 conditions. The time parameter is enhanced because time delivery is flexible. Performance is constrained because must meet the operational standards, and cost is accept because we have a large budget range. Overall, the final classification is a resource constraint project. For the resource allocation method, in this part, heuristic rules are applied because it is practical and gives a fast solution for a complex problem. We use this heuristic method to get our schedule network diagram, as shown in this diagram here. And then we use the network diagram to get, it's also applied to assign responsibility assignment matrix, which is in our report, and the OBIs. This ensures that our project is optimized and follows a resource-driven schedule.
To conclude, our EMP defense system is designed to protect important military equipment from powerful EMP attacks. We use proper planning and economic analysis to compare 3 different versions of the system. Among them, option 3, the mobile command and vehicle-based system, turned out to be the best, and as it gives more flexibility and protection in the field. Overall, this project improves the safety and readiness of the Johor military force and helps make sure that they can continue working even in difficult situations. So that concludes our presentation. Thank you very much.